You know, we've all had that moment. You accidentally nudge your desk and the monitor just flickers for a second.
Right.
It's annoying, but you just kind of wiggle the cable and, move on.
Yeah, and it's fixed.
Now, imagine that desk is vibrating constantly, and it's moving at, say, 60 miles per hour, and it's -4 degrees outside.
And you can't just wiggle the cable
Exactly.
because that monitor is bolted to the ceiling of a subway car, and you are, I don't know, 3 cars away.
That is the engineering nightmare we are looking at today. We're doing a deep dive into the NTI VOPEX-M12VA-4. On the surface, it's an industrial VGA splitter and extender. But when you actually look at the specs, it's really a case study in how to keep digital signage alive in environments that want to kill it.
It really is. Most people think of tech as the software, maybe the screen resolution.
Mm-hmm.
But in mass transit or heavy industry, the real tech is the ruggedization.
Mm-hmm.
If you put a standard office splitter on a train, the vibration alone would just destroy the connection, probably in days.
So let's get into how this NTI unit handles that. The basic function is pretty clear. It takes one video source, like a passenger info system or a safety warning, and it scales it out to 4, 8, or even 16 remote monitors.
Standard distribution, yeah.
But the form factor is completely different from what you'd find in a server room.
And the biggest giveaway is right there in the model name,
Mm-hmm.
the M12 connectors.
Right. Okay, so standard VGA cables have those little thumb screws, or sometimes just a friction fit. I'm guessing those don't hold up when you're rattling down a track.
Not a chance. The M12 system it's totally different. It's a circular threaded connector.
So it actually screws on.
Exactly. You don't just plug it in, you torque it down.
Oh, okay.
It's designed specifically to resist all that shock and vibration. It effectively makes the cable part of the chassis.
Which explains why the documentation focuses so heavily on rail transportation. It solves that physical disconnection problem. But then you have the distance issue. This isn't just splitting the signal. It's pushing it 600 feet, that's over 180 meters, using a standard CT5 cable.
And that's the extender part of the name. That distance is critical in these industrial settings. Think about a train station platform. The computer running the schedule isn't behind the screen.
Of course not.
It's in a climate-controlled room a football field away.
Yeah.
You need to push that analog signal all that way without it just turning into static.
Speaking of climate control, that's another place where this thing really diverges from standard gear. I was looking at the operating specs, and the temperature range is massive. But practically speaking, does that wide range actually matter, or is it just over-engineering?
Oh, it matters immensely. We aren't talking about a cozy office. This device might be installed in the utility box out in a train yard. It has to survive a Chicago winter, then 6 months later, bake in that same steel box during a heat wave.
With no fans.
With no fans to cool it down. So yeah, it's a huge deal.
So it's built like a tank. Powder-coated steel, no moving parts.
Exactly. It's set and forget.
Well, let's talk about that forget part. The datasheet lists the mean time between failures, the MTBF, at over 593,000 hours. I mean, that is nearly 70 years. I have to play devil's advocate here. That number feels a little theoretical.
Oh, it is.
Does it actually mean this one box is going to run for 70 years?
No, not for a single unit. It's a statistical probability. It's not a guarantee. But think about what that number represents to, say, a transit authority.
Okay.
It means the failure rate is incredibly low. If you have 1,000 of these installed across a city's subway system, a high MTBF means you aren't paying technicians overtime every week to go climb ladders and swap out dead units.
Ah, so it's an operational expenditure stat, really.
It is. In this context, reliability is the #1 feature. The 1920 by 1440 resolution is great, and the fact that it can carry audio for announcements is useful. But none of that matters if the screen goes black because a connector shook loose.
It just becomes invisible infrastructure.
That's the whole goal. When you look at a departure screen, you're not supposed to think about the hardware. You just need the information. This NTI unit is the thing ensuring that information gets from the server to your eyes, regardless of the heat, the cold, or the shaking.
It definitely changes my perspective on my morning commute. So next time you're on a train or in a busy airport looking at a screen, maybe take a second to appreciate the specialized engineering, specifically those threaded M12 connectors, hidden behind the wall, just gripping onto that cable for dear life to keep the picture steady while the world shakes around it. Thanks for joining us on this deep dive.